Now we're on record. So, good afternoon, everyone. Welcome to the class. Before I move on, I want to find out if I'm audible enough. So, can you guys hear me?
Yes, please, sir.
Okay, that's fine. So, let me share my
Yes, sir.
screen and then we move on. Today, we're looking at inductive reasoning. In our last class, we were discussing deductive reasoning. And we said it is reasoning where the relationship between the premises and the conclusion is logical. And we said that just like mathematics, the meanings of the contents of the argument don't matter at all. What matters is just the relationship between the premises and the conclusion. Either it is a valid modus ponens, a valid modus tollens, or it's a valid hypothetical syllogism, or it's a valid deductive syllogism. So it can be valid, but it is not true, or it is not sound, you know. So the meanings of the words in the arguments are not what make the argument correct. What makes the argument correct is the structure, the logical structure of the argument, that it obeyed the law, the deductive laws. You know. So an argument could be valid, but it is not true. Whether the argument is true or not is up to you. It's up to the person who formulated the argument. So what you need to know is that they are valid but unsound arguments, you know. All that matters is the logical nature of the relationship. But for the inductive reasoning, when you come to inductive reasoning, the relationship is not logical. It becomes possible to affirm all the premises and deny the conclusion without contradiction. So this is what we need to note about inductive arguments. It is possible to affirm all the premises and deny the conclusion without contradiction. In our last example of an inductive argument, we said 95% of men are honest. Peter is a man, therefore Peter is honest. We saw that we can have two conclusions. We can have Peter is honest, Peter is not honest, because Peter could be among the 95% of honest men, or he could be among the 5% of men who are dishonest. So there are two possible conclusions to the argument. What it means is that the argument can go with a negative conclusion and the argument will still be correct. You can say 95% of men are honest, Peter is a man, therefore Peter is not honest. You can also say the other one. So in an inductive argument, it is possible to affirm all the premises and deny the conclusion without contradiction, because the premises are capable of producing more than one conclusion. So in that case, you need to look at the meanings of the contents and then use your common sense to determine for yourself whether the argument is, something you should believe or not. There's no issue about inductive arguments are not correct. They are not strictly correct. They can only be close to the truth. You can say they could be close to the truth, or they could be close to being correct. They are probability arguments. Someone raised her hand. Priscilla. Priscilla, did you raise your hand? Okay. So inductive arguments.
Sir, please, it's a mistake.
Okay, good. And so inductive arguments. So for this type of argument, premises provide reason for believing in the likelihood of the conclusion, but the premises do not guarantee the conclusion. So this is the opposite of deductive reasoning. Deductive arguments are guarantees. They are logical guarantees, but inductive arguments are likelihood arguments, which do not provide guarantees. So inductive arguments are probability arguments, because inductive arguments do not depend on rules. They are harder to evaluate. So it is harder to evaluate inductive arguments. When you have an argument saying that Peter is honest, Peter is not honest, it is harder to evaluate, because you are dealing with two contrary premises. You have to do more homework before you know which premise you want to accept. But if you are dealing with a deductive argument, you don't need any homework. There's only one conclusion. So that is what we mean to say that it is harder to evaluate inductive arguments. Before we go into inductive arguments, we need a few clarifications. So we need to distinguish, first of all, between verifiable and confirmable statements. Verifiable statements are statements we can directly test or verify. They are usually factual or empirical statements. So a statement you can verify directly. Kofi is 9 feet tall. You can verify it. Ghana is 2,000 miles from Accra is 2,000 miles from the capital of Togo. You can verify that. So verifiable statements are statements you can directly test or verify. They are usually factual and empirical statements. Example, Kofi lost strength with age. So Kofi lost strength with age. You can test, you can verify it because you know what Kofi could do at a younger age, and you know what he can do now. So if he can't do the things he used to do at a younger age, it means he lost strength with age. That means that the statement Kofi lost strength with age is directly verifiable. Then we have confirmable statements, statements that we cannot test or verify directly, except through verifiable statements. So there's nothing you can do about verifying confirmable statements. You can only use verifiable statements to support or reject confirmable statements. Example of confirmable statement, all men lose strength with age. So you cannot directly verify all men lose strength with age. You can only educate yourself on that by looking at verifiable statements, such as Kofi lost strength with age, John lost strength with age, James lost strength with age, and those things. So confirmable statements are statements that we cannot test or verify directly, except through verifiable statements. We can combine them. Verifiable statements are normally premises. Confirmable statements are normally conclusions. And that is how you build your inductive arguments. Inductive arguments are normally made from verifiable statements as premises and confirmable statements as conclusions. Kofi lost strength with age. Peter lost strength with age. Michael lost strength with age. James lost strength with age. Therefore, all men lose strength with age. So verifiable premises and confirmable conclusion. The conclusion is supposed to be confirmed or disconfirmed by the premises. Inductive arguments are normally used in sciences. So the conclusion is usually called a hypothesis. The conclusion is usually called a hypothesis. Hypotheses are confirmable statements. Statements you confirm so that you can use verifiable results or data to confirm or disconfirm them. So when you formulate a hypothesis, it is a confirmable statement. It is technically the conclusion of an inductive argument. Even if it is an inductive argument where you don't have the premises yet, you formulate the hypothesis and then you start doing experiments. The experiment will start generating data. The data is described with factual statements, and then the factual statements are the premises. So if you have done your experiment or you have gathered your data, you have your data, and then you use statements to describe your data. The premises here are the kinds of statements that describe the data you have collected. Kofi lost strength with age. Peter lost strength with age. These are the results of a research. Michael lost strength with age. James lost strength with age. And then your hypothesis for that experiment is that all men lose strength with age. So inductive reasoning is the reasoning that is used for scientific experiments. So the premises are verifiable statements leading to conclusion, which is unverifiable or confirmable statement. Another example, Mary reached menopause by 40. Grace reached menopause by 35. Meredith reached menopause by 33. Rose reached menopause by 34. Edith reached menopause by 38. Sophia reached menopause by 45. Therefore, half of all women reach menopause by 35. If you look at the premises, you see that half of the women reach menopause by 35, half before 35 or by 35, and then the other half reached it after 35. So the conclusion, which is also a hypothesis, is was gotten or was confirmed by the premises, or you can say you reached it on the basis of the premises. How do you detect confirmable statements? There are two ways of detecting confirmable statements. First of all, they are not directly testable or verifiable. So we said that already. Second is that you can convert them into conditional statements. Example, look at this categorical statement. No leader steps down from power unless compelled by a coup or constitution. No leader steps down from power unless compelled by a coup or constitution. You can convert it to a conditional. The conditional translation will be, if X is a leader, then X will not step down unless compelled by a coup or constitution. So that means that this statement can be converted into a conditional statement. Any statement you can convert into a conditional statement is a confirmable statement. So these are the two ways of detecting confirmable statements. First of all, you cannot directly verify them. Secondly, you can convert them into conditionals. Now, let's make another distinction, which we made in our last class, between finite and infinite reference classes. We said in our last class that finite reference class is a class of countable items. Examples, this copper, that man, some boys, that table, and so on. But the infinite reference class is a class of uncountable items, items you can't count. Example, all metals, all men, all voters. So we're making that distinction here because we want to use it for the next slide. Now, we need that distinction here because, like I told you, the conclusion of an inductive argument is called a hypothesis. Now, there are two kinds of hypotheses. So that means there are two kinds of conclusions of inductive arguments. We have the law-like hypothesis and the statistical hypothesis. Now, the law-like hypotheses are confirmable statements that refer to all members of a class. That is, statements with infinite reference class. Example, all metals expand when heated. That's a law-like hypothesis. All metals expand when heated. It is a law-like hypothesis because it refers to all metals. It refers to all members of the metal class. But a statement that refers to some members of the metal class is a statistical hypothesis. 80% of metals, that's a hypothesis of 80% of metals expand when heated. That would be a statistical hypothesis. Now look at this law-like hypothesis. All metals expand when heated. Convert it to a conditional. If X is a metal, then X will expand when heated. We have other examples. All Fs are Gs. Each F is a G. No Fs are Gs. All Fs are not Gs. Now, law-like hypotheses are highly predictive. That is, G must be attributed or not attributed to every F. If you say all Fs are Gs, then it means that G is attributed to every F. All men are mortal. If Peter is a man, then Peter is mortal. Anything that is man is very predictably mortal. The prediction is absolute, it's 100%. But if you say some men are mortal, and you say Peter is a man, then the prediction is less. The prediction is not absolute. It's not as strong as that of a universal statement or a law-like hypothesis. Statistical hypothesis, confirmable statements referring to some percentage less than 100 or more than 0. So example, 90% of those who ate the food fell sick. So, statistical terms include some, few, many, most, hardly. So it's not only percentages. You also have other terms that tell you it is statistical. We say it is less predictive. If X ate the food, X is likely to fall sick. Now, this is the difference. If you say 100% of those who ate the food fell sick and X ate the food, then surely X will fell sick because it is 100%. But if you say 90% of those who ate the food fell sick and X ate the food, then it is less likely that X will fall sick. X has 90% chance of falling sick. But if it is 100% of those who ate the food that fell sick, then X will have 100% chance of falling sick. So that's why we say law-like hypotheses are more predictable compared to statistical hypotheses. Confirmation versus proof. Inductive arguments are aimed at confirmation. Now, confirmation doesn't mean the kind of confirmation we use in ordinary life. Ordinarily, we say confirmation is something like proof or guarantee. But in this course, confirmation is not as strong as proof or guarantee. Confirmation is something like support, but it is not as strong as proof or guarantee. Inductive arguments are aimed at confirmation. Deductive arguments are aimed at proof. Confirmation is not proof. Now, another problem with inductive arguments is that evidence is limited in its ability to prove something. Ordinarily, we think that evidence, has 100% capacity to provide you guarantee that something is true. But in science, evidence has some limitations. Let's see the limitation of evidence. Before we go to that, we will see the limitation of evidence when we are looking at an example of an argument with law-like hypothesis. So we're coming to that very soon. Let's look at this first. Two major ways to detect inductive arguments. So how do you detect inductive arguments? There are two major ways. First of all, inductive arguments are capable of more than one conclusion. We already know that. 90% of those who ate the food fell sick. Amma ate the food. So we have Amma fell sick, Amma did not fall sick. But another way of detecting inductive arguments are extrapolations. An extrapolation is an activity that smuggles in information into the conclusion that is absent in any of the premises. So an argument that smuggles in information into the conclusion that is absent in any of the premises. So all inductive conclusions contain information that is not accounted for in the premises. Now let's look at the technicality. This is the reason why. This is how an inductive argument works. A known thing A has certain properties such as X, Y, Z. Another thing B that is not in the premises has the same properties, X, Y, and Z. A also has some additional property Q. On the basis of the above three premises, the argument concludes, in reality extrapolates, that B also has the additional property Q. So you have two things. You have A, you have B. The two items have three identical properties, X, Y, and Z. Now, because they have three identical properties, one day you notice that K has another property, let's say X or Q. And then you say, okay, because you already know that A and B has three identical properties, if A has X, then B could also have X. But the argument is not really valid because you have not confirmed that B has it. You are just guessing, you are just using the idea of likelihood to conclude that B will also have Q. So the idea of induction then is that if B is like A in some respects, it may also be like A in other respects. Now let's look at several directions of extrapolation. Now we have said that inductive arguments are extrapolations. You extrapolate from something to another. I know extrapolate is like guesswork. Now let's look at different ways that inductive arguments appear. That is different directions of extrapolation. First of all, you have path-hole extrapolations. Now, I got this information from the critical thinking textbook that it's at the university bookshop. There's this critical thinking textbook. It's colored red and black. So I got it from there so that you'll be able to detect inductive arguments in whichever way you see them. We have part-whole extrapolations, that is attributing something to a whole that constitutes a part or parts. We have two types. We have generalizations and you have statistical syllogisms. So generalization, Peter is strong, James is strong, all men are strong. This is a generalization. So generalizing from Peter and James to all men. Okay. Then we have statistical syllogisms. Most Canadian university students drink alcohol, or 90% of Canadian university students drink alcohol. Caroline is a Canadian university student, therefore Caroline drinks alcohol. So this is a statistical syllogism. That's the first type of inductive argument we saw in our last class. Then we have analogies, arguing that something possesses the same thing as another because they both possess some other properties. So this is similar to the explanation I made with A and B having similar properties. So this is an argument by analogy. Something possesses the same thing as another thing because they both possess some other properties. Let's see an example. The structural adjustment program was good for Cameroon, which is a third world country. The structural adjustment program was good for Uganda, which is a third world country. The structural adjustment program was good for Senegal, which is a third world country. The structural adjustment program was good for Nigeria, which is a third world country. Therefore, the structural adjustment program must be good for Togo, which is a third world country. So this argument is arguing that this program will be good for Togo because it was good for 4 other countries. And why is it assuming that it will be good for Togo? Because Togo and the other 4 countries have something in common. What do they have in common? Because they are third world countries. So arguing that because 2 things have a common property or some common properties, they could also have another new common property because one of them has it. Then we have predictions, attributing a quality to a future event because of the level of frequency of past occurrences of the same quality in similar events. Attributing a quality to a future event because of the level of frequency of past occurrences of the same quality in similar events. Tyson has won his last 30 boxing fights. Therefore, Tyson will win his next boxing fight. So you can see that the premise offers you reason to believe in the likelihood of the conclusion, but the premise is not a guarantee for the conclusion. So there's no guarantee that Tyson will win his next boxing fight because he won his last 30 boxing fights. So this is a prediction. Prediction is another form of inductive argument, just like analogies, part-whole generalizations, and statistical syllogisms. So those are the different ways that you will see an inductive argument, the different directions of extrapolation. Now let's look at 2 kinds of inductive arguments based on their strength. When we talk about the strength of an inductive argument, we're talking about how close an inductive argument is to being correct. So now we have two kinds of enumerative inductive arguments based on strength. Enumerative argument means an argument with many premises, enumerating the premises like a list. So the first kind of inductive argument is the one with law-like hypothesis as conclusion. The second one is the one with statistical hypothesis as conclusion. So we're saying that an inductive argument is an argument where there is an information that was imported into the conclusion, which is absent in any of the premises. Now we're going to see that. Now, so arguments with law-like hypothesis as conclusion. This is an example. So this is an experiment about expanding metals by heating them. Gold expanded when heated, silver expanded when heated, bronze expanded when heated, copper expanded when heated, and so on. So 10 metals expanded when heated. And then the summary premise tells you that all the metals tested so far, which is metals 1 to 10, expanded when heated. Then the conclusion is that all metals expand when heated. Now there's a difference between the summary premise and the conclusion. The summary premise is talking about all the metals tested so far, all the metals. And the conclusion is talking about all metals. Remember, I was telling you that all the men and all men are not the same. All the men could refer to all the men in this class, all the men in this town, all the men in this country. They are countable. But when you talk about all men is not countable. Here you are seeing all the metals in the summary premise. And in the conclusion, you are seeing all metals. So all the metals in the summary premise are countable. All metals in the conclusion are not countable. So that means that you have the premises and even the summary of premises are particular statements, and then the conclusion is a general statement. So this argument is jumping from the particular to the general. So that means that there is a piece of information in the conclusion that is not in the premises. What is the information in the conclusion that is not in the premises? It is the information about generality, information about all metals. There is no information about all metals in any of the premises, or even by combining all the premises, you can't find any information about all metals. So an information was stolen into the conclusion that is not in any of the premises, or the conclusion tries to provide information that is absent in any of the premises, that is not accounted for by the premises, either individually or collectively. So that's another way of detecting an inductive argument. So because there is some information in the conclusion that is not in the premises, that particular information has not been argued for. It is just a presumption. It is just sitting there in the conclusion without any defense, Premises 1 to 10 are verifiable and particular statements. The summary premise is a summation of all the verifiable premises. Then the conclusion is a confirmable general statement. So the argument is strictly invalid because it involves jumping from verifiable to confirmable statements. So that's the reason why confirmation is not proof and inductive arguments are not valid. So the conclusion is in fact false because there are some metals that actually don't expand when heated. So if you are reaching conclusion that all metals expand when heated, because you saw that 10 metals expand when heated, you are taking a risk because you have not yet discovered all metals. And as it turns out, there are some metals that were discovered later which don't expand when heated. We now call them superconductors. They don't absorb heat, so they can't expand. So the conclusion is false and all the premises are true. So that's why we say it is possible to deny a conclusion with all true premises or to affirm premises and deny conclusion. And this is applicable to all the types of extrapolation, from the part-whole generalizations to the analogies and then to the predictions. So now we are done looking at the inductive arguments. We can now make some comparisons between inductive and deductive. So how do you compare inductive to deductive? What are their advantages or disadvantages? By now, it is already clear that that deductive arguments are accurate, whilst inductive arguments are not really accurate. So we know that already, but there are certain things we don't know. Now, let's look at the first one. Deductive arguments are accurate at the expense of the inability to provide the information. So deductive arguments may be correct as mathematical equations, but they are not able to provide you with information, valuable information about the world, or new information that you can work with. For example, either it is raining or it is not raining. This is a disjunctive syllogism. Either it is raining or it is not raining. Disjunctive statement. Now, this statement is correct. It is always correct. If it rains, this statement is correct. If it doesn't rain, this statement is still correct. So whether it rains or not, statement one will always be correct. Either it is raining or it is not raining. But does it provide you information about whether it is raining? It doesn't. It doesn't tell you whether it will actually rain. So that's why we say deductive arguments are accurate at the expense of the inability to provide information. Okay, number two, statement two is another example. If it is raining, then someone will get wet. So that's the kind of thing you see in a deductive argument. It's a conditional statement. If it is raining, someone will get wet. But does it tell you whether it is raining? No. Now, the statement is always correct. If it rains, someone will get wet. So the statement is correct. If it doesn't rain, someone will not get wet, unless someone gets wet through another means. So the statement is correct. Whether it rains or not, the statement will always be correct. But whether it tells you, does it give you information about whether it will rain or whether it is raining? It doesn't. So deductive arguments are accurate at the expense of providing information, valuable information. On the other hand, inductive arguments provide information at the expense of accuracy. So it is the other way around. Now, it means that the disadvantage of deductive arguments is actually the advantage of inductive arguments. And then the advantage of deductive arguments is the disadvantage of inductive arguments. So the advantage of one is the disadvantage of the other. So providing information is to be falsifiable. When you provide information, the information you've provided is falsifiable. Example, it is raining right now. When you say it is raining right now, it provides information about whether it is raining. That's a valuable information because you can use it. If you know that it is raining right now, you can avoid going out so that you don't get beaten by the rain. So that's a valuable information that it is raining right now. But is it falsifiable? Yes. Any statement that provides information is falsifiable. If it is not raining, then the statement is false. So that means the statement is falsifiable. It is only true when it is raining. So that's why we say any statement that provides information is falsifiable. Now, falsifiability and science. Any valuable empirical information must be falsifiable. Any statement that is not falsifiable cannot be a verifiable or confirmable statement. Any statement that is absolutely true has no empirical content. The more valuable the information, the more falsifiable it is. So the empirical statement, it rains every third Friday of the month, is more valuable information than it rained just now. Now, these two empirical statements, in order to find out which one is more valuable to you, you need to ask yourself, what would you benefit from the two statements? Now, if you know that it ranges now, you can, do some things today, only today, that will take account of the fact that it ranges now. You can go out and till the soil, you can go and cultivate the land because the ground is wet, but it's just for today. The information is just for today. So whatever you are doing is just for today and probably just part of tomorrow, the early part of tomorrow. And that's all. That's the value you can get. But if you know that it rains every third Friday of the month, then it means that every third Friday of the month you can go to farm, or you can every third Saturday of the month you can go to farm, and then you can till the soil because the soil is wet. So that means that what you are able to achieve with the first statement is more than what you're able to achieve with the second statement. That's why we say that the empirical statement, it rains every third Friday of the month, is more valuable information than it rained just now. But the more valuable, the more falsifiable. So it will take only one third Friday of not raining to falsify that statement. So it is easier to falsify empirical information that provides more valuable information than to falsify the one that provides less valuable information. So what it means is that the more the information, the more the falsifiability. Now let's look at the second type of inductive arguments, arguments with statistical hypothesis as conclusion. So this is an example. So this is an experiment of people who were vaccinated and those who continue to suffer and those who stopped suffering. Michael was vaccinated for polio and never suffered polio. Gilbert was vaccinated for polio and suffered polio. Mary was vaccinated for polio and never suffered it. Stanley was vaccinated for polio and never suffered it again. James was vaccinated for polio and never suffered. Bob was vaccinated and suffered. Jill was vaccinated and never suffered. Samuel was vaccinated and never suffered. John never suffered. Carol never suffered. So the summary premise is that 8 out of 10 people who were vaccinated for polio did not suffer polio. So 8 people stopped suffering polio. Only 2 people continue to suffer it. So the conclusion is that polio vaccination has 80% chance, 80% potential of preventing polio. So 8 out of 10 is 80%. So that's the conclusion. Now that conclusion is a statistical hypothesis because it's referring to 80%. It refers to the finite reference class, particular statement, Yeah, so this is an argument with statistical hypothesis as the conclusion. And you can see that it is a stronger argument compared to the last argument, the argument with the law-like hypothesis. When you say 10 metals expanded when heated, because of that, you say all metals expand when heated. That's a very weak argument, but this one is a safer argument, So we have 2 types of inductive arguments, the ones ending with law-like hypotheses as conclusions, and then the ones ending with statistical hypotheses as conclusions. Hypotheses are technically regarded as conclusions of inductive arguments because they are confirmable statements to be supported, confirmed, or denied by verifiable statements. So this is the end of the class. We shall do causal reasoning next week. If anyone has questions, you can ask. After that, I will upload the video and those who couldn't attend the class can watch. So any questions?
Yes, doctor.
Yes, go ahead.
Please, I don't really get the extrapolation.
Yeah, extrapolation is to move from something that is known to something that is unknown. Extrapolation is like sort of guessing, So you can read it in the dictionary so that you see the meaning clearly, and then when you watch the video, you return to those particular slides and see why we describe it as extrapolation.
Okay, thank you.
Yeah, you're welcome. Okay, so I hope you all did your assignments. Remember that these assignments are best done in the middle of the night between 12 and 2 a.m. because that is when you have the best network or the strongest network. When you do your assignments during the day, then you are taking a risk. And remember, you have just 2 attempts. If you miss the 2 attempts, then that's a serious problem. Okay, so I'm going to end the class and then I'll upload the video. We shall be meeting on Friday by this time. And until then, I wish you good luck. Keep working hard so that you'll be great. Goodbye.
Thank you, sir.
Thank you, sir.
Okay, sir.
Bye.